Hey, what is up, guys? Quick update here. Wanted to show you how I align this motor before I get it all set and wrapped up. I'm working on motor mounts right now. I know it's actually been a while, but I had a hard time fitting this thing in. Anyways, basically what I do, I put an angle gauge here, and I see what tilt the driveline angle is at, okay? And then I also want the engine square to the chassis like this, okay? So I initially started off and I ran a string all the way to the back of the car, basically the center of the back of the car all the way up front. That gives me a true straight line to reference off of, so I don't have to reference off of, you know, say 16 inches off this frame and 16 inches off that back frame. You know, the frame's actually, I don't know if you know this about Fox bodies, but it's curved in this area. So you can't just pull a linear dimension off the frame rail like I did my truck. So what I did that string, and then I had various strings that go across horizontally like this, and then I marked using like a plumb gauge. I think that's what it's called. Anyways, so I marked various areas on the chassis. Okay, so I know where a true straight dead line is, and then I did a reference to the center of that mark from this chassis, from this frame rail, and I did the same to the back where the train's output shaft is. So I pulled the dimension there and I pulled the dimension in the back. And I'll kind of show you how I pulled that. Go underneath the car quick. So I have a plumb bob, okay, this is kind of screwed up, but anyways, I have a plumb bob hanging from here, and then here's one of those horizontal strings, and you can see my mark. So I pulled the dimension from this frame rail to here, and then I would match that dimension to basically the center of the output shaft. So yeah, pretty cool. I'll show you the mount quick. So I made those two plates. I made the motor plate and I made the plate that attaches the K-frame. And then I was able to pull the dimension between the two and then tack something in place. So right now it's just tacked in place. Oh, also, it's very handy to have a couple of ratchet straps. Basically, so I found crankshaft center line to this frame rail, locked that dimension in, and then I slowly played with the back one just to fine tune it. My final dimensions are 15 and 5/8. I'm sorry, 14 and 5/8 here, and 13 and 3/8 in the back. And that actually left me with plenty of room for my universal. So my universal joint's going to go there. I had to watch how close I was to the exhaust, and then took the intake off just temporarily so I can use this as a reference point. This is a great reference point for the block. This surface is in line with the crankshaft center line basically. So angle gauge here, I'm going 1.5 degrees down, and then I laid an angle gauge horizontally like this, and I want to be 0 here, and that's with the chassis level. Okay, so I did that initially, and then I was able to pull those dimensions and get everything fine-tuned. You can see I have a jack in the front on the just the oil pan here, And then I also have a jack in the center, and that kind of just helps me fine tune this thing, right? So this is very critical for, obviously you don't want your driveline angles, you know, to kind of crisscross, right? So you don't want your engine down and then your differential down, because that actually forms a bending moment on the drive shaft, and that's how you break drive shafts. So if you're having, you know, any kind of drive shaft vibration issues, I would check this out. Another good reference point is the damper, but you got to be careful because this outer sheave ring, the inertia ring, it will actually move back and forth. Learned that the hard way because I actually measured thrust, and I go, man, what the heck? So it turns out this will actually move because this is rubber, so it's not permanently fixed. Anyways, this is your best point right here. All right, I'm going to finish welding these up. Keep you guys updated. Thanks. Bye.